Think math.
Here is the same data, tabled twice. One has a clear peak and the other is flat as a board, and the data was never touched. Only one thing changed: how wide the boxes were that we poured it into. What is width? That it can do that. Names first. Each interval the data goes into is called a class, and how wide that interval is called the class width. 140 up to 150 is one class, and the 10 that spans is the class width. They get separate names because they do separate jobs. Push the width to its extremes. Make it very wide and everyone lands in one or two boxes, and the peaks and valleys vanish. We set out to group the data and flattened it instead. Make it very narrow and each box holds one or two people, and it comes out jagged. That is no better than the pile of digits we started with. More important still is keeping the widths equal. If one box spans 10 and another spans 20, the wider box looks busier purely for being wider. Catching twice the fish in twice the net does not mean the fish were thicker there. Only equal widths let you set the frequencies side by side. That is why the class width has a name of its own. The class tells you where a value is put, and the class width tells you whether you can trust what the box says. Read the frequencies without checking the width, and you are comparing catches without asking how big the nets were. So, the class is the box, and the class width is how wide it is. The width decides what the picture looks like, and equal widths are what make the boxes comparable. Next time, how we choose a single value to stand for everything inside one of those boxes. See you in the next one. A sip of math every day here at Think Math.